Imagine a museum that houses very important collections. It's heavily guarded with a fully armed security system. One night, the security guard forgets to lock the museum's doors. An intruder sneaks in and heads for the museum's most prized item. On the way, they trip the laser alarm and are caught. Luckily, the museum's collections are all safe. Our body is just like the museum. Its immune response helps to protect our organs against attacks from pathogens like viruses or bacteria. And fevers are built-in traps like the laser alarm. They help the body to get rid of the pathogen, but are also a sign of illness. In fact, a fever is one of the symptoms for COVID-19. Fevers have been around for over 600 million years of evolution, but they come at a steep cost. For every 1 degree Celsius increase in body temperature, there's a 12.5% increase in the energy required, or about 20 minutes of jogging. Because the energy cost is so high, it's important to make sure that your body doesn't induce a fever when it doesn't need one, like a laser alarm that's only activated during a break-in. The brain's hypothalamus controls this switch for a fever. It's also responsible for thermoregulation, or the set of processes that keep your body's core temperature around 98.6 degrees Fahrenheit. It can detect minute shifts in body temperature and send signals to the body accordingly. If you're too hot, the hypothalamus produces signals that activate your sweat glands or make your blood vessels dilate, moving blood closer to your skin's surface, which releases heat and cools you off. If you're too cold, your blood vessels will constrict, and you may start to shiver, which generates heat. The hypothalamus disrupts this temperature equilibrium when it induces a fever, which sets in above 100.4 degrees Fahrenheit. But it has mechanisms in place to prevent it from exceeding 105.8 degrees when organ damage could occur. Immune cells that are fighting an infection will release pyrogens, which trigger the hypothalamus to increase your baseline temperature using the same mechanisms it would to generate heat when cold. A fever's main effect is to induce a whole body immune response. The higher temperature will trigger some cells to release heat shock proteins, or HSPs. These proteins help lymphocytes, one of many kinds of white blood cells, to travel more quickly to the infection sites. They do this by enhancing their stickiness, enabling them to adhere to and squeeze through blood vessel walls so they can reach the infection. During a viral infection, HSPs signal cells to decrease protein production. Since viruses depend on their host's machinery to reproduce, this stunts their spread. Meanwhile, the body's first responders, like macrophages, can destroy pathogens tagged by antibodies, limiting their path of destruction inside the body and keeping your organs safe.